Hey!
All right. Yeah.
Yeah!
Rationalizing the denominator.
Woo! Yeah!
All right. This is the first video out of like 50 videos ever done live. So this is fun with Set 3 Algebra 2.
Woo!
To rationalize the denominator. All right. All right. To rationalize the denominator, we multiply. We multiply the top and bottom of the fraction by this exact expression. All you got to do, it's a very easy process. You just multiply the top and bottom by whatever this expression is. Root 2 in this case. All right? So now we have to do 2 times root 2. What is 2 times root 2? Elisa? I'm kidding. Go ahead. I'll keep going. What is 2 times root 2? 2 root 2, right? 2 root 2. And then, sorry, that should be a root 2, I bet. Root 2 times root 2 is what? Root 4, which is just 2, right? Whenever you multiply a radical by itself, remember this, I said this in class 20 minutes ago, but whenever you multiply a radical by itself, what was underneath will be the answer. So we get 2 root 2 over root 4, which becomes 2. And now you see a 2 times root 2 on the top and a 2 down there. You can just cross off the 2's. And now it's root 2 divided by 1, which is root 2. Thank you. So the key, guys, it's really a one-step problem. All you have to do is multiply the top and the bottom of the fraction by that radical. All right, and you just combine the top. You get 2 root 2. You multiply these radicals. You got 2 in this case. The 2's cancel. You're left with root 2. Another one. This one. We don't need to worry about the 5. All right, if it was 5 plus root 3, it would be a different story. I'll do that in problem 3. It's just 5 times root 3. So still, we can just multiply by root 3 over root 3. 6 times root 3 is 6 root 3. Now, 5 root 3 times root 3.
Root 9. 5 root 9.
5 root 9, which becomes 15. Good. 5 root 9, or 5 times 3, is 15. Okay? Good. Good teamwork. Now, we can simplify a little bit further because 6 over 15 is a fraction we can simplify. What is 6 over 15 simplified to? 2 fifths, right? Because 3 goes into both. So that becomes a 2, that becomes a 5. Our answer is 2 root 3 over 5. Now, once again, the whole goal is to rationalize the denominator. The denominator was an irrational number. 5 root 3 is an irrational number. All right, now, the number 5 is a rational number. It can be expressed as the ratio of 2 integers, right? 5 over 1. Is this still on the thing? Yeah. We are here. Let me. Yeah. Awkward silence. All right, now, the last type, we have 3 minutes left. I can do this. This is totally different. We do not multiply by root 3 over root 3. Whereas we did that in number 2, we don't do that here. When you have a binomial, you have 2 terms, meaning addition or subtraction on the bottom. This is a harder problem. This is where all the foiling we've done, like yesterday night's homework, comes into play. All right, this is where the foiling, the distributing, is really important to know. We multiply by what's called the conjugate of the denominator. So we don't just multiply by root 3 over root 3 when we have 2 terms. We multiply by the same expression, but we change the symbol in between. So if it was a minus, it would become a plus. All right? So now we might want to put the binomials all in parentheses. All right? The top becomes 10 times 4 minus root 3, or 40. Right? 10 times 4 is 40. We've got to distribute minus 10 root 3. So the top becomes 40 minus 10 root 3. This is what we always do when we have 2 terms in the bottom. And here, we FOIL. But as one student last night chose to do some even problems, you see when you multiply conjugates, a lot of stuff wipes out. Right? 4 times 4 is 16 when we FOIL. Then we get, look, I'm not going to write all this because of time, but we get negative 4 root 3. Right? 4 times negative root 3 is negative 4 root 3. And this is positive 4 root 3. So they wipe out. That will always happen. When you're foiling with conjugates, same expression but opposite signs, the O and the I of FOIL, the outsides and the insides, will always drop out. Negative 4 root 3, positive 4 root 3. They're done. And then what is positive root 3 times negative root 3? Negative root 9, which is negative 3. Right? Positive times a negative is a negative, so be careful with that. And now we just clean up anything we can. 16 minus 3 is 13. And the top? Guys, what does the top become? What is 40 minus 10 root 3? What is 40 minus 10 root 3? This is me waiting. Can't do it. Good. Thank you. 40, it's not 40 root 3, right? Yeah. So that's the answer. So just to quickly review, when it's just one term in the bottom, one radical, we multiply by the exact same thing. Those are a lot easier. All right? And then we simplify if we can. In number 3, there was a binomial down here. And we have that. We multiply by the conjugate. And we'll have to do some distributing and foiling. It's a longer problem. All right? Yeah. Thank you.